All right, I'm going to work on the Unit 2 practice. There are 5 questions there, and I'm going to work on them one by one. Let me make it a little brighter. Okay, so number 1, this is MTH162 Unit 2. All right, now number 1, there's a function y equals -3 cosine x over 3 plus pi. Okay. I give it this function. I ask you for the amplitude and the period, and I ask you to graph one period of this function. So the general form looks like this, right? A cosine b x minus c plus d. So basically, we need to look for what is a, what is b, what is c, what is d. Obviously, this a is a 3, -3. So the amplitude is the absolute value of a, which is just 3. So this is the amplitude. Okay, and the b is the coefficient of that x. So my b equals 1/3. Can you see that? Right? And then from here, I know the period. Period is the parent function cosine period, which is 2 pi, divided by b, 1/3. 2 pi over b. So the answer is 6 pi. Okay, now here is the tricky part because I need to get a c. How should I do that? I have x over 3 plus pi. I need to write that in this form, which is b, which is 1/3, then x minus c. So I need to find out the c. Do you see that when you distribute this 1/3 into this parenthesis, you also get pi, x over 3. So cross out with that. So the left side, I have pi, and the right side, I get a negative c over 3. Therefore, I get my c. I multiply by -3 both sides, so the c is -3 pi. Okay, so that's c. And what about d? In this example, my d is just 0. So I have a, b, c, d. All right, now I'm going to graph. Because I know a, b, c, d, I'm going to graph. Now let me give you a quick little reminder of the parent function, which should look like this. Isn't it? Okay. So in that part here is 2 pi. This period is 2 pi. But right now, my period is 6 pi. So I'm going to extend. I'm going to extend that from 2 pi, 4 pi, and 6 pi. So if I am going to do, for this one period, I'm going to stretch all the way to here, right? That's how I work with this. And what about this A? A is the amplitude. So I have to enlarge that. I stretch that vertically. This is 1. So I need to stretch vertically by a factor of 3. So 2, 3. So then I have this. Isn't it? So from 1 to 3. But it's negative. So I am going to start flipping. And I will have something look like this. 6 pi, so it's going to be this. All right, so I did a -3, right? Because I did the stretch by 3 and a flip. And I get my b, which is the period, go from 0 to 6 pi. And then I have a c, I haven't done that yet. And a d, I don't worry about that because I'm not shifting. I don't talk about that right now. Now I need to talk about this x equals -3 pi. So this is the function starting from a 0 top, which is here. And if you have a -3x, which means, you see here, oh, I didn't write that in the good form. Gee, right, that y equals -3 cosine, okay, 1/3 over Here should be x minus c, x plus 3 pi. It should be like this. Okay. All right, now, do you see this x plus 3 pi, which means I'm going to shift this to the left by 3 pi, isn't it? That's what we learned in the function transformation. So here is the 3 pi. Therefore, my graph should look like this, which means I shift to the left by 3 pi. Okay, so here is my graph. So it's from -3 all the way up to +3 and then down to -3. And here is the 3 pi because the period is the 6 pi and I move this to here, so this point should be -3 pi. So that gives me the whole one period. So the red one, let me just highlight that again. So the red curve is my graph. Okay, do you see the idea? This is the number one. All right, now number two, I know you don't really like graph. I'm sorry. Y equals 2 tangent x minus pi over 4. Well, this looks much easier because we only need to worry about this and this. Remember, it should be A tangent B x minus c plus d. And in my case, A is 2. Okay, B is just a 1 because the coefficient of that is 1. And since this is just x minus pi over 4, so I know my c is pi over 4, and my d is also 0. So I got the A, B, C, D. And I ask you to graph two full period parent function. Remember the parent function go from negative pi over 2 to positive pi over 2, and you have something like this. You have symptoms, right? So here's pi, here's that. So let me just keep going. Okay, that's 2 period. But then let's see what happened. First of all, let's see, I go x minus pi over 4, which means I need to shift to the right by pi over 4. Did you see that this is pi over 2 and pi over 4 is right here? So I'm going to shift this a little bit. Okay, before I have a negative pi over 2, I have a positive pi over 2, and then I get a pi, and I get a 3 pi over 2. So I will shift the curve like this. That's my parent function. Okay, I need to shift it to here. So I will shift also this point. I go like this. Everything just shifted to the right. By a quarter of a pi. Next is this 2. I need to stretch vertically by a factor of 2. So here is pi over 2, here's pi over 4, then that's a 3 pi over 4. I should give a little bit more space. And this is 5 pi over 4, and a 6 pi over 4. Okay, so it should be like 3 pi over 2, and then I go 7 pi over 4 to here. So I will have the vertical symptoms looks like, because before the symptoms should be pi over 2, but I shifted by a quarter. So here we'll shift also by a quarter. This is negative pi over 4. And then, because I have a 2, so instead of having, when it's, when here a quarter pi here is 1, I have to multiply by 2, but when I shift it, so I have here should be 2. Okay, and here's negative 2. Therefore, do you see this graph? Okay, so the middle should be like that. And the same thing, you just copy it to just show me that is the period. So that'll be good enough. So this, the red one, will be your graph of this. 2 times the tangent of x minus pi over 4. Okay, so this is the second question. You see what I ask you to do is I ask you to know how to graph it, okay? So number 3, and I ask you to find the value of the following expression. The first one, cosine inverse negative 1/2. Okay, if you remember the cosine function, okay, so let's see. The answer I will get is an angle. So let's call that theta. Therefore, cosine theta should be negative 1/2. And cosine is from the angle should go start from 0 to pi, and the value go from positive 1 to negative 1. And when it's negative 1/2, it's right here. So this is my angle, which is 120 degrees, or 2 pi over 3. Okay. You can also tell me that is 180 degrees. That is totally fine. Or 120 degrees. So this is A. And B, cosine tangent inverse 3 over 4. This is not quite obvious, but this is an angle. So let's say this is the theta, okay, which means I know tangent theta is 3 over 4. Actually, I can draw the graph. Use the right triangle, which we learned the first unit. Here's a 3, here's a 4, and here's a theta, isn't it? So for this theta, tangent of that is 3 over 4. So tangent inverse of 3 over 4 is just this theta. Can you find what is a cosine theta? 3, 4, and this is 5. So cosine theta should be just 4 over 5. The answer is 4 over 5. You can just tell me 4 over 5, or you can tell me 0.8. But this shows you how to use the right triangle to solve this problem. All right, now C, tangent inverse negative 2. Okay, tangent inverse negative 2. You don't really know because we don't really see this negative 2 very often. We don't know that. So let's just use the calculator. Okay, when you use a calculator to do tangent inverse, you always do second. So you have the tangent inverse, but you're going to be very, very careful whether you're using degree or radian. Since here is RAD, so I'm using degree. Then I will go tangent inverse of negative 2, close it. So that's a tangent inverse negative 2 equals. So my answer is a negative 63.43. You can keep 2 decimal places. That's good enough. But this is super important. You have to have the degree because you're using the degree. Okay, so your answer is negative 63.43 degree, or if you use a radians, okay, never mind. So if I use radian, and then tangent inverse of negative 2 close, let's see what you get. You get negative 1.11. Okay, so either way. But if you just write down the negative 63.43, it's a wrong answer. You have to have this little degree there. Okay, so this is the number C. And then we're going to do number D, which is a cosine inverse negative 1.2. This, when you take the inverse function, you are going to get an angle. So theta, okay? And I have a cosine theta is negative 1.2. But we know for the cosine function, it should be always between negative and a positive 1. So there's no way we can find this theta. I get this terrible cosine value. So this one does not exist. Or you say undefined. It's the same thing. Undefined. Okay. This is the number D. Okay. Now let's work on number 4. And the number 4, I ask you to solve a right triangle, and I give you this triangle. A is 8, and C is 10. Can you solve it? So then let's see this triangle. This is A equals 8. This is a C equals 10. So here's a B, I don't know. This is the angle. Sorry, this is the angle B. This is the angle A. And this is the angle C. That's a right triangle. So if I ask you to solve this, okay, first of all, I know for the Pythagorean theorem, A squared plus B squared should be the same as C squared. So A squared is 8 squared plus B squared equals 10 squared. So 64 plus B squared equals 100. I minus 64. So B squared is 100 minus 64. I get 36. Very easy. I got a B equals 6. So I have a 6, 8, 10. Next, I know this is 90 degree. As long as I find one of that, I'm okay. So let's use A. Sine A. Sine A should be the opposite, which is 8 over 10, or 0.8. Therefore, A is sine inverse 0.8. Let's see what is that. Okay, so again, I'm using the calculator. I use the calculator to get a sine inverse 0.8. You can do 0.8 sine inverse equals. This is the radian, okay? I'm using radian. If you use a degree, then that is totally fine. So let's see. I use a degree, 0.8 sine inverse. I'm still using radian. Sorry, let me put. Right now I'm using degree. So 0.8 sine inverse equal. I got a 53.13. So 53.13 degree. And the B is going to be just 90 degree minus 53.13 degree, which is 36.87 degrees. So I have an A, I have a B, and also I know C. And remember that I always do this. A equals 8, B equals 6, and C equals 10. Angle A is 53.13 degree. Angle B is 36.87 degree, and angle C is 90 degrees. So I would prefer to write it like this. Okay, so that is number 4. And one last question. Number 5. Okay. A ball on a spring is pulled 6 inches below its rest position. So which is this? So you have a spring, and here's a ball. So you pull it down 6 inches, and then you release. So the period for this motion is 4 seconds. We know the period is 4 seconds. Okay. Write the equation for the ball's simple harmonic motion. So let's say this is the rest position. What happened after you pull it down by 6 inches and you release? The ball is going to go back and then down, up and down, up and down, up and down, right? Keep going. So the graph will look like this. Here's the X, and here's a Y, here's the position. So when the time is 0, which is -6, okay? And then the period is 4. So 1, 2, 3, 4. After 4 seconds, 1, 2, 3, 4, it go back to here again. But in the middle, it will reach to here. So it will go here. All right. Up, then down. It's going to go look like this. So middle line, and it's going to here. Okay, and you can, of course, keep going. So this ball is going to bounce up and down. It's going to jump up and down. And I asked you to give me the graph of this. Okay, now I will use, okay, this is a sine. I have to start from the middle. This is a cosine. I have to start from the top. This, I'm going to start from the bottom. So I am going to use negative cosine. That's for sure, right? And then I go y equals a cosine b x minus c and then plus d. But the thing is, I start from the very bottom, so there's no c. So c should be 0. All right, now I need to find a, b, c, d. And remember, a is the amplitude, which should be the maximum minus a minimum over 2. And in my case, the maximum is 0, the highest point, and the minimum is negative 6 over 2, so that is 3. So I know A absolute value of that is 3. The amplitude is 3. However, it's going to be negative. So my A is going to be negative 3. All right. And I'm looking for B now. So B is going to be the period is the period of the parent function cosine, which is 2 pi divided by b. But I know the period because the period is 4 seconds. So which means 4 equals 2 pi over b. And you multiply by b divided by 4. So your b is going to be 2 pi over 4 or pi over 2. So that's your b. I got an A, I got a B. A C I already know is 0. What about D? D is the middle position. So that's the maximum plus the minimum over 2. That is 0 plus negative 6 over 2 is negative 3. So I know A, I know B, I know C, I know D. So the function f of x will be negative 3 cosine, because the C is just 0, I only have a bx, so b is pi over 2x plus d. D is negative 3. All right, I have my function of that. This is the question number 5. That's it.